Yeah, Pradeep Kumar here. Here I am going to tell you about the move and the simulation of urban mobility software called as SUMO software. That how to process this software. I am going to tell you a demonstration here. Now using that software, we can generate traffic models for roads. That what we create, as well as we can generate traffic model for a real map across the globe. So for example, if we want to generate a traffic simulation for a particular road or a highway in a particular city, for example Chennai in India, for example, we can able to generate traffic for that using this piece of software. So I am going to use two different software. One is called as Move. The software name is move.jar is a file. Another is SUMO 0.12.3. It is a software that I am going to use. So this move.jar will be working only under this version 0.12.3, but the current version of SUMO is 0.21, so which will not be supported by this move.jar. Actually, SUMO is a software that just generates XML files needed for generating the traffic simulation. So again, it is case sensitive. So you need to be very careful in designing the junctions, roads, types, configuration, everything. It's case sensitive, and we need to design that. So in our example, we are going to see a simple simulation. So this is my road traffic. So we have these junctions are called as the junction points. That is, there is a traffic signals here. So 0, 1, 2, 3, 4, 5. Totally there are 6 junctions. Among that, I want to have traffic signals at these 4 junctions, because this is only a single junction wherein I may not need a traffic signal here. But this is a junction of three roads: this road, this road, and this road, this road, this road, and this road. So similarly, these 4 junctions have 3 roads joining at a center. So I would like to have a traffic signal here. And for example, if we want to have a coordinates here, so I just want to give this as for usually I can start with 100 comma 100, and between these two I can give 200. So you can consider this as meters or whatever you can have. And the edges, these are the roads. So each road may will have 2 lanes here in this case. So if you want to have 3 lanes or 6 lane roads, you can able to process that. So I will be having 2 lanes per road. So I have, for naming convention, what I have done is I have used R01, means between 0 to 1 there is a lane here. R means moving right, so means that the source node is 0, the destination is 1. And between L01 means left hand side, so it is 1. Again use the same naming convention, 01, that indicates that 1 is the source and 0 is the destination. So U for up and D for down. So 04 means between these 0 and 4. This will be between 1 and 4. Like this, I have I have the naming convention for all these roads. And for better option, you can have a coordinates also. So make this node this 4 node 4 to be 300 comma 100, and this will be 500 comma 100, so that the y-axis is maintained 100 here. And in this case, the y-axis will be up above. So 100 comma 300, 300 comma 300, 500 comma 300, and 700 comma 300 you can maintain. So these are the 6 different coordinates that I will be having. So now we'll come to the software, how to generate this road map pattern. So the command here is java space -jar move.jar. So this is the command where I will be having, I should be running this, opening this move.jar file. So in this case, what happens is it's a jar file, so I need to have JDK installed on this machine, so that I can able to use this move.jar file. So once I press enter, so I will be creating a window like this. So there are two things: one is the mobility model, another is the traffic model. So this mobility model generates road map topology and vehicle movement. That simply it will be doing it. So once I click this mobility model, I have so many options like this. So for the first time, you can seem to be confusing this, but once you start working on it, it will be very easy to handle it. For your option, this same software will be working under both Windows as well as Linux, but I am using Ubuntu here, so I will be demonstrating this in Ubuntu itself. So first thing is, when I create node, you will get an empty screen like this. Since I have already created a pattern, so I will just simply open that. So since it's a video, so if you want, you can pause the video and then record the data. See that I have given the naming as N0, N1, N2, N3, N4, N5, and by N0 the location is 100, 300, and there is no traffic light. And similarly N1, 300, 300, there is a traffic light. So for all these 4 nodes we have traffic light. For 2 junctions we don't have any traffic light. So once it is done, you can save it, but as of now I just quit it because I already saved it. So this will create a file called as node.xml file. Similarly edge, so edge you can see that, so this is the road here. So I have already created the, so just what I do is I'll just go with the edges. So edges I have these many edges. See L01, R01, L12, R12. I have given the from node to node, and type of the roads I have not mentioned. So for example, in countries like India, we have national highways, state highways, 6-lane roads, 4-lane roads, like that. We have so many options. But here I would like to, I don't want to specify any type of the roads. So if you go for a real traffic modeling traffic simulation for a transport by a transport office, they can think about the road type of the roads. But as of now, we don't need any type of the road, so I just leave it blank. And the number of lanes is 2 per road, and the speed I can maintain is 40 kilometer per hour. But in countries like European countries, they can move have a various speed ranges in various roads, so they can customize this speed. But across the country India, we have only 40 kilometer per hour I use. And priority of the roads is 75. So if I have 100 vehicles, 75 vehicles will be using these lanes, so that's why I make as priority as 75. So if you have 50 vehicles, means 37.5 vehicles will be moving in this road. Remaining 12.5 vehicles, we don't bother about it. So that's how the priority of this roads is set. Now that is done. So once nodes and edges are formed, edge type is optional because we are not specifying any road type. If you want to specify any road type, so then you can prefer this edge type. Next thing is we'll go with configuration. So in the configuration, first we have to give the input and output files. So first I'll give the input file node.xml file, and the edge file edge.xml file. So since we have already created that, so we have a node and edge file, and we don't have any types file, so we leave it as it is. And the output file name, so what is the name of output file name? I want to make it as net.xml. So for the better convention, you can use all the name, the first name always to be common, so that it belongs to the same network. And the maximum speed is given as 40, so I make it as 40, and then save this file. So when you save this file, it will ask for net configuration.cfg. So save this file in this context, vanet.netc.cfg. So once you do saved it, ensure that you save it again and then quit it. So once it is quit, so we got the configuration ready. So our next step is going to create map. So now the map generates the pattern for the road. So create map. So click here and vanet.netc.config, that you click it and click OK. Now in this case, you should get a success image here. So success word here that indicates that, so we have got the junctions ready. So priority junctions are 6 junctions, and it tells you all other steps also. So how many dummy edges we are removing, how many edges, what kind of shape it has, and everything, traffic light logistics, everything is been generated here. And click cancel. So we have done a map. So map means the map pattern what you have designed as per this diagram is been designed by this map. So that will be specified by net.xml file. Yes. Once it is done, we have to go for a flow meter. So flow meter indicates, flow indicates, so in what direction I want to make a flow here. So for example, I have designed two things, D04 to L23. Begin is 0 is 1000. So 0 to 1000 means 1000 seconds approximately, and 25 vehicles are been moving from this edge to this edge. I will name it as F0. So you can have your own name, any name, but maintain that it is case sensitive. So you need to follow the sensitiveness case. And in this case, we have a F1 here, R12 to L45. So for example, I will go with D04 L23. So you can see that D04 is here and L23 is here. So what the route is, D04, it will come here, the vehicle can come here, go to R45, then U35 and L23. So I am just designing a network in such a way that the flow is D04, R45, U35 and L23. But this is not the only route. So sometimes my vehicle can go like this, D04, then I can take a U14, then I can take a R12, then I can take a R23 and take a U10, and then I come to L23. So this is also possible here. So either I can go with two different routes, or the third route D04, R45 and U25, and then R23, and can go like this. So this way also the routes is possible. So in anyhow, I need to set the priority for these routes. Now when I come here, now I want to first set the flow. So I have set the flow. Similarly, the second is R12 to L45. See that R12 is here and L45 is here. So R12, R23, D35 and L45. This is the route. Similarly, I can come directly here, or I can go like this here, or I can take a U-turn and come like this. So we can have any number of routes is possible in this case. Now for how the nodes will turn around, so that we'll see in the next thing. So I close this. Yes, so now I will come with the turn. So turn indicates, turn also I have already done it, so I'll just go with the turn here. Now I want to give 4 turns here, so it means that D04 to R45 80% of the vehicles will turn, and D04 to U14 20% of the vehicle will turn. So R45 U14, see that D04 U14 20% will be turning here, and remaining 80% will move towards this location, because we cannot expect that all the vehicles will move in the same direction. So I want to have a probability of 80% will of the vehicles will move in one direction and 20% will move in the other direction. So that I have done it here. Similarly for the other route R12 D25 R12 R23. Similarly 10% of the vehicles move in one direction and the remaining 90% of the vehicles move in other direction. And then you save this as done. Yes, it is saved. So once it is done, I'll come flow and turn is done. So trip for each vehicle types. If you want to have a trip, let's say for example, if a local bus or a local transport office, if they want to have a trip meter, so they can use this. Now we create manual vehicle movement. So in this case, when I create a vehicle, so the create a junction turning radius, because we have a flow and turn definition file. If you want to have a trip file, you can give this. So in our case, we have a flow file. So click this. Flow is being selected, and turn definition file. Click the turn.xml, and then we have already have a map XML file. So in which map, and we are going to create a route file. So these are the two files very important. So when you want to have a map file and a route file, both are very important in terms of handling this vehicle movement. So click OK. So this will generate the steps needed for moving the vehicle. So for ensuring you can click full of time, so that you can get the complete data and success. So between steps 1 to 999, that is from 0 to 1000 seconds, the route has been computed, and then close it. So our vehicle type is over. Now next thing is we'll come to configuration. So in the configuration, we'll just because now our purpose is not to just see the model simulation model. We want to see the NS2 model. So how many packets are dropped. So I want to have a VANET kind of simulation. That's vehicular ad hoc network simulation I want to see. So I'll be using this. So I'll create a trace file when I want to output a trace file. So the name of the trace file is .sumo.tr file. So when this file is saved, it will be saving a file called sumo.config. It's a very important file. So this is a sumo.config file that will be running under the Sumo software. Okay, so that is done. So for insurance, you save it. So in this, this is a very important thing. The configuration, we have to give the map file and we have to give the root file. And then if you want to have a NS2, TCL file creation, if you want to have, then you can use the sumo.trace file. If you feel that okay, I don't want to go for NS2, then you can disable this, no issues. Then file quit. Now visualization. So when we visualize, automatically the Sumo GUI will open. So this Sumo GUI, it is not as easy as to install in any of the Linux operating system, because it has some issues, some software issues, some dependency issues. But in Windows, it successfully installs it. But if you want to run NS2 or TCL file, again you have to come back to Linux. So this this operating system Ubuntu 12.04, I have tried it and I have installed Sumo 0.12.3. You can see this in the top left hand side. Sumo 0.12.3 is the software version. Move supports only this version. Okay, so now when I click OK, vanet.sumo.config, and here is my road. So my road is been open now. So now when I increase the delay, so if you have a less delay, the cars will move very fast. So I like to have a simple delay here, and I'll go. There are 3 standards here: standard, faster, and real well. I'll go with real well standard. Okay, and then I like to start the simulation. You can see that the vehicle started moving. So we have started from D04 here. So when it is D04 and it comes here, and some of the vehicles will move here, and there also L23 also we have started, and some vehicles take a U-turn here. And for example, if you want to take this is a signal here, so we have given a traffic signal at 4 places, so you can able to see the demonstration here. So this is the signal. So green indicates the vehicles can move, so red indicates the vehicle has to wait. So this is one, and here see that for red the vehicles are waiting, and otherwise the vehicles are so this is how. See, some of the vehicles comes here, some vehicles will take care as per the flow whatever we have designed it. So this is a perfect simulation that what we have designed the road. Now we can compare this with our diagram. So ours is like this, and this is what the real actual simulation. So this is how we will do the SUMO simulation. I'll close it, and once it is done, so we can see how many vehicles have been running in this simulation, and how many emitted vehicles. So when you see that emitted vehicles are 50, totally 50 vehicles we have designed, but running are 49. So for 49 vehicles are running, total duration is 337 milliseconds, and a factor and UPS. So simulation ended at time 1000 seconds. So this is my mobility model. So this mobility model generator for VANET is over. So that's why we call it as a software move here. Now next thing is traffic model. So this is very important. So when it come to traffic model, so it is creating NS2 and QualNet. So you can use either of this. So since we were very comfortable in using NS2, we go for static mobility, and we have NS2 and we have NAM here. So first I will go for static mobility. So in this static mobility, first it will give the channel type, file, physical layer channel, drop tail queue, omni antenna, AODV protocol. So all these parameters already will be populated by this software directly, and we need to fill up these boundaries. I mean these topology boundary. We may not know what is the topology boundary, so we have to import some data externally from the mobility model. So for that we have a file menu, import trace. Please remember we already created a file called as .sumo.trace file. So that file we have to import it here. Click OK, and this is the sumo.trace file. Once it is opened, it will ask for net.s. There is a map file. So we'll open the map file also. So once we open both these files, you can see that the flow ID. So this is the flow ID, but in this case of NS2, this flow ID is nothing but nodes. So you can count the number of nodes, 1, 2, 3, 4, like this. You can get the number of nodes. So we have designed total 50 vehicles, but may not be exactly 50. There may be around 52 or 53 nodes will be there. Now we need to set the parameters. Now see that this parameter topology boundary has formed, and simulation stop time is formed. Number of mobile nodes is 50. Now if you want to make a router trace, NAM trace, movement trace, MAC trace, everything we make it on, and set the NAM file. So I can set as vanet.nam, and trace file. This is for tracing, vanet.trace. And if you click this button, only generate mobile node movements, you will not create any traffic. It will create only the movement of the nodes. Only the vehicles will move. It will not happen anything. Okay, now we'll add a connection. So for example, if you want to add two connections, I mean traffic generators. So I click TCP or UDP. So for reliability, I will go with TCP here. Now start time is 0, end time I will make it as 1000, and here also I will make it as 1000, and start time I will make it as 0, and source ID. So you can say, so we will go with this as my source node, this will be the destination node. So the command here is f0_0. So this will be the source, and here destination will be f0_1. Similarly for the second bucket, I will go with f12, f13, f1_2, and maybe in future I can say f1_7 we can take, f1_7. So once it is done, file save. So when you save the file, it will ask for the TCL. So vanet.tcl is the file that I have saved it. So save it, quit. Now either you can use run NS, you can click this button here, or if you know the command ns filename.tcl, you can directly run in the console. So better I will go with this now. I'll go with vanet.tcl and click OK. Now sometime I may wait, because the number of lines in this file may be very huge, and this software may take some time. So let us wait for a quite number of times. So you will be getting the screen like this. So once it is done, you will click cancel, and then come here, click NAM, and give the name of the file NAM. So in this case we have vanet.nam, and click OK. So this will open NAM file. This is the network animation. So you can see that you can see that it exchanges packets, So we have given only two different traffic simulation, that is f0 underscore 0 to f0 underscore 1, and f like that we have given two traffics only. So if the nodes are nearby each other, so they can able to transmit the packet. You can see that there are two kind of traffic simulations going on. Since it is TCP, there is some acknowledgements also going on. You can see that the packet is transmitting here and there is acknowledgement going. Similarly here there is an acknowledgement is moving. So this is how we will do the simulation. Now once the animation is getting over, so you can see from we have given from 0 to 1000 seconds. So usually the processing of 0 to 1000 seconds will take some time, since I have disconnected the video in between, so that's why the time is totally took me around 3 minutes of a 4 GB RAM machine. It uses 3 minutes of my time to get the entire file getting processed, and the packets are still getting exchanged, and see the vehicles moving as per the map what we have created in the beginning. So this is what the map it is getting created, and as well the same thing the flow of node happens in the network. So once it is done, so if you want to do some result analysis, then we may not need this NAM. So I'll close this NAM file. It's okay. So better I'll just include this like this. So the NAM file is getting. So if you want to run this NAM file, you can do this way also. NAM, so you can use this way, NS VANET.tcl also you can run it rather than running through GUI, or you can use NAM VANET.NAM. You can use this way also. Now we are going to process this file. So there is a software called trace graph, so wherein we can directly analyze the trace file. Since again this trace file is having huge number of lines, the processing of this trace file will again take some amount of time. So till the results are getting till the packets are getting populated here, we need to wait it. Anyway, I am going to disconnect the video again. After it's populated, I will do it again. Yeah, so this file vanet.tr approximately around, the size of the file is around 165 MB. So as you see here, the size of the file is around 165 MB, and the total number of lines in this file is crossing 26 lakhs number of lines. So which is physically not possible. So which is physically handling is a very tougher task for handling this file. So I can see the number of lines is 21,69,193 lines. So this I have tried my level, tried my level best, but the trace graph software is processing more than 10-20 minutes. I have been waiting, so it still take more time. So we have to process these files using the AWK scripts or Perl script for processing the languages. So if you have any other queries related to this VANET software and SUMO, this and MOVE, so you can always refer my website www.nsnam.com. So this is my website where I host all my materials related to Network Simulator 2, and shortly Network Simulator 3 also is coming up, and about all the wireless networks, wired sensor networks, VANETs, MANETs, and everything related to that, it will be displayed in my website. So thank you for your time. Thank you very much. So I am Pradeep Kumar.